So I want to simplify the square root of 96. There's two different ways you could do this. The first way I want to show you is by using a factor tree. So 96 breaks up into 2 and 48. 2 is a prime number, so it can't be broken up further, but 48 can be broken up into 24 and 2. 24 can be 12 and 2. 12 is 6 and 2, and 6 is 3 and 2. So I'm looking for any pairs that I might have inside of 96. It looks like I have a pair of 2's, which brings 1, 2 out in front of my radical. And I have another pair of 2's, which brings another 2 out in front of my radical. Left behind at the base of my factor tree, the roots of my factor tree, are 3 and 2. So inside the square root, I have 3 times 2 remaining, leaving me with 4 root 6, since it's all multiplication. Another way that I could have done this is I could have seen that 96, the square root of 96, could be broken up into the square root of 16 times the square root of 6. If I'm using the second method, I'm really trying to find what perfect square is a factor of the number that I'm trying to simplify. So 16 is a perfect square, and it's also a factor of 96. So I break 96 up into square root of 16 times the square root of 6, giving me 4, since that's the square root of 16, times the square root of 6. You can pick which method works best for you. So when I have variables underneath the square root, I want to start thinking about doing each one separately. So it's almost like I'm going to be doing the square root of 18 and simplifying that, and the square root of x to the 4th and simplifying that, the square root of y to the 7th and simplifying that, and the square root of z all separately. So the square root of 18, I can use my factor tree to break 18 up into 9 and 2, and 9 into 3 and 3, showing me that I have a pair of 3's to bring a 3 out in front of the radical and a 2 left behind to stay underneath the radical. So a 2 stays underneath. X to the 4th, if I think about it, x to the 4th is really x times x times x times x. And so if I'm looking for pairs, this pair of x's tells me that I can bring one x out in front of my square root. And this pair of x tells me that I can also bring a pair of x's out in front of my square root. If you think about it, this is really x to the 4th raised to the 1/2 power. And when I have a power to a power, that gives me x squared, because 4 times 1/2 is 2. So a whole x squared is going to come out in front, because I really had 2 pairs of x's to cancel. Or if I think about it in terms of a rational exponent, I was simplifying it to x to the 2nd. If I look at y to the 7th, y to the 7th has 3 pairs of y's within it, because if I do 7 divided by 2, it goes in evenly 3 times, leaving me with a remainder of 1 y that's going to have to stay inside the square root. If I look at z, z is really to the 1st power. There's no pairs of z's, so z is not going to be able to make it outside of the square root, so z has to stay inside the square root. So my final answer is 3x squared y cubed root 2yz. So a rule in math is that we don't leave square roots in the denominators of fractions. So to get rid of the square root of 7 in the denominator, I want to multiply the square root of 7 by the square root of 7. Because the square root of 7 times the square root of 7 by our product of radicals rule tells me that it's really the square root of 49, 7 times 7, which I know to be 7. So when I multiply a square root by itself, I get just the number underneath the radical. Another way to think of this is 7 to the 1/2 times 7 to the 1/2, which is 7 to the 1st power if I add the 1/2 power plus the 1/2 power. So multiplying the denominator by 7, root 7, leaves me with no radical in my denominator, which is what I want. But if I'm going to multiply the bottom by root 7, I also have to multiply the top by root 7. So I get 2 root 7 over 7 is my simplified version. Okay, so I have 3 over 2 root 18. So I want to start off by rationalizing my denominator. So I'm going to do that by multiplying top and bottom by the square root of 18. That gives me 3 root 18 in the numerator over 2 times root 18 times root 18 is 18. So I really have 3 root 18 over 36. I can do one of two things right now. I can simplify the square root, which I'm going to have to do anyway, or I can make my job a little bit easier and see that 3 and 36 really have a common factor of 3, and I'm going to divide top and bottom by 3, giving me root 18 over 12. 3 divided by 3 gave me 1, and 36 divided by 3 gave me 12. I do have to keep going and take the square root of 18 and simplify it. So square root of 18, as I saw earlier in the video, gives me 3 root 2, pair of 3's and a 2 left over 12, which I can then simplify by dividing top and bottom by 3 again to give me root 2 over 4 as my final answer.